Okay, so the last example, we could do either a disk method or a shell method. The next problem we're looking at, though, has to be done with the shell method. So same setup, find the volume of the region formed by, etc., etc. So we're bounded by y equals x e to the x cubed, x-axis, x is 0, x is 1. Sometimes you'll see that last part written as just x's on the closed interval 0, 1. Both of those mean the same thing. And we're going to revolve about the y-axis. All right, so as far as working out a quick sketch, doesn't have to be a work of art. We know our endpoints are 0 and 1. 0 times anything is 0. So we know we hit the origin. Plug in 1 for the x. We have 1 e to the first, or just e. And we have some kind of curve happening here. We're revolving about the, again, y-axis. So here is our shape, and if we were to want to use the disk method on this, we'd have to be able to solve this thing for x, and it's, in this case, not possible. So there are some cases where it's either difficult or impossible to isolate the x. In that case, shell method may be easier. So let me draw our little representative rectangle again. So here is our P of, in this case, x. Here's our h of x, and width of that rectangle would be delta x. So the volume, 2 pi anytime you're using the shell method. Integral from, in this case, 0 to 1. X was on 0, 1. So radius, 0 to x is just x. Height, x e to the x cubed. And the thickness of the rectangle, dx. So a little cleanup there. Volume then is 2 pi integral from 0 to 1 of x squared e to the x cubed times dx. And hopefully you recognize this as an e to the u type situation. If you recall, the derivative of e to the u is e to the u times du. So working backwards, if I wanted the derivative of an e to the x cubed, I know I'd have e to the x cubed involved. So let's bring the rest of the stuff along. Differentiate this part, again ignoring the 2 pi for a minute. Derivative would be e to the x cubed times 3x squared. I see the x squared, I don't see the 3. So we multiply by 1. Multiply by 3 here and 1/3 there. Cancels out, it leads us to a 1. So now we have 2/3 pi times e to the x cubed. I guess I didn't need quite that large of a gap in between. I just kind of wanted them to line up nice. And we're going from 0 to 1 on that guy. So our volume then, 2/3 pi times e to the 1 cubed is still 1. 0 cubed is 0. So our volume is 2 pi e over 3 minus 2 pi over 3. E to the 0 is, of course, a 1. Cubic units. And you'll see that either in this form or you might see it in the factored form as well. Either one of these two are fine with me. All right, so again, in that case, the disk method / washer method was not possible since we could not solve this guy for x. All right, all centered. Okay, and our next one. Our next example, we start revolving about something other than just an x-axis or a y-axis. So we're going to take y is x cubed plus 2x plus 3. Y equals 3. And x on the closed interval 0, 1. And we're going to revolve about the line. There's a little ugly little triangle on the end of my circle. Here, I'll draw a prettier version. Revolve about x equals 2. Okay, so first, a little bit of work setting up our sketch. So here's my y-axis, here's my x-axis. Again, we're only on the interval 0, 1. So plugging in the 0, we have 0, 3 on here. And trying out a 1, we have, let's see, 1 and 2 is 3, 3 and 3 is 6. And we have some type of curve going on there. We also cut it off at y equals 3. And again, x is 0 to x is 1. So we have this little wedge shape. But instead of spinning around the y-axis, around the x-axis, we're going to spin around the line x equals 2. So again, let me start with my representative rectangle here. And we have a couple of adjustments to make because we are cut off this way and coming at it from a different way. But if we stick with sort of labeling things the way we have been, so here's our p of x. Here down only to here is h of x, in other words, not all the way down to the axis, just where we were told to stop. And our width still is delta x. So shell method, volume is 2 pi times the integral of radius, height, and thickness. So our radius here, if I plug in an x value, let's say x is, a half. Then this radius here, from a half to 2, is 1.5 units. We would find the difference, 2 minus the input. Think of it if, we'll do one more sort of mini example. If x was at a 1/4, then from 1/4 to 2, that is 1 3/4, 2 minus the 1/4. So 2 minus x is our radius, p of x. Height of this comes from our x cubed plus 2x plus 3. But we also want to subtract 3 we're cutting off the bottom part of that rectangle. We don't want to go all the way down to 0. We want to stop at 3, so we'll cut off the bottom 3 of the height. And delta x, as usual, turns into dx. Okay, so then clean up here. Volume 2 pi. Oh, my bounds, they were just given this time, 0 to 1. 2 pi integral from 0 to 1 of 2 minus x by x cubed plus 2x. The plus 3 and minus 3 will drop, times dx. We'll FOIL those guys out, and then we'll just do our antiderivative. All right, so we have x cubed by minus x is minus x to the 4th, x cubed by positive 2 plus 2x cubed. 2x by minus x is minus 2x squared, and 2x by 2 is plus 4x. Close it up. Don't forget to bring your dx along. So our volume, hang out of that 2 pi still. Now we're just doing power rule. We just happen to have 4 terms instead of 3 terms like before. X to the 4th turned into x to the 5th. I don't see a 5 here. I do see a -1, so -1/5. X to the 3rd becomes x to the 4th. To get a 2 there, 4 times 1/2 is 2. Again, if you need to use the 2 over 4 first and reduce it to 1/2, do it in 2 steps, that's fine. X squared becomes x cubed, so we'll need a -2/3 there. The 3's drop when you do the derivative. The -2 stays there. Last one, x to the 1st is now an x squared. 2 times a positive 2 would give me the positive 4 that we have out front there. And we're grabbing those between 0 and 1. So in our volume, 2 pi times 49/30. 49 pi over 15. The 2/30 turns into 15, and this is also cubic units as well. All right, questions? Oh, apology. Okay, so the questions that I usually get on that one, can we look at one more like that? That one had a lot going on. So what I'm going to do is sort of do the initial setup, and I'm going to ask you to pause the video, run through it, and see what you can do. See if you can figure it out, and just unpause the video when you're done and see if you come up with what I came up with. So find the volume of the solid formed by revolving the area. I'll just put ... that same intro we've done on all the problems in the last 2 sections. We're going to take y as x to the 5th plus x plus 2. Y equals 2. X is 0, x is 1. And we'll spin it around the line x is 3. So give that a pause, see what you can do, and unpause it when you're done, and we'll finish it out. Okay, welcome back. So we'll make our quick sketch here. So trying out the 0, we have 0, 2. Trying out the 1, we've got 1 and 4. Some kind of curve happening between them. We're not going all the way down to the x-axis. We're stopping at y equals 2. And we're spinning this around the line x equals 3, so not to scale, obviously, but spinning it around that way. So our representative rectangle, here's our p of x, h of x, again only going down to here, and delta x. So our volume, 2 pi, since we're using the shell method, integral from, we're told from 0 to 1. Our radius would be 3 minus x. So if we try it out at x equals 1, the radius would be 2. We went from 1 to a 3. If x were a half, going from a half to 3, 2.5 units. 3 minus whatever x was is your radius this time. Our height, we're getting the top part from x to the 5th plus x plus 2 minus, don't forget to cut off the part we're not using. So that is 2 units tall, the part we're chopping off. And our thickness is dx. So volume 2 pi, integral from 0 to 1, hang on at 3 minus x for a minute. Our second factor, x to the 5th plus x, times dx. So volume 2 pi, integral from 0 to 1. And again, we'll just multiply this out. So minus x to the 6th plus 3x to the 5th minus x squared and plus 3x, close it up, times dx. So in our volume, 2 pi times x to the 6th is now x to the 7th. To get a negative 1 there, I need a negative 1/7 out front. X to the 5th is now x to the 6th. 3 over 6 is the same as half. X squared becomes x cubed, so I'll need a negative 1/3 out front. 1/3 times 3 is 1, and bring your negative. X to the 1st is now x squared, so plus 3 halves. The 2's drop, leaving you just the 3 if you differentiate. And we'll evaluate that between, again, the given 0 and 1. So our volume is now 2 pi by 127 over 42, which is 127 pi over 21 cubic units. All right, so some problems to try out in 7.3. I'll do 1 through 25 odd, 29, and 31. If you have any questions, please feel free to get in touch with me. Thank you.